Alright, so we are ready to put some blown-in insulation up here. I'm going to put about 18 inches. It's going to be about 120 bags. We're using cellulose. I haven't used the cellulose too much. I've done it a few times, but it's been probably 15 years since I've done it. Usually I use the fiberglass. But it was quite a bit more money for the fiberglass on a big project like this, so rather than waste $400 or $500, I just did the cellulose. I know it settles a little bit, but kind of is what it is on this garage. So I've made kind of a catwalk going down the whole middle, so that way when this is all said and done, that's about 2 feet off of the bottom. I can have a place to walk to run wires later on or something. I also made another catwalk at the end of there going that way, because that's where my solar is going to be ending, so I wanted to just have another platform to penetrate the roof with the solar wires. I've also framed out an opening that's 18 inches tall. So that should keep all the insulation out of this area. And then when we're all said and done, we'll take like 2 layers of 2-inch foam and make a door there. So right now I'm waiting on my air to water heat pump, so I figured this is a good time to get this done, get this nice and insulated. That way when I install my heat, I can be all done. All right. Man, now I think I remember why I switched to fiberglass. This stuff is super slow, really dusty too. I remember that fiberglass stuff isn't dusty at all. I was trying to save a few $100s, but I almost think I should have just went with the fiberglass. We'll be here all day and all night. All right, so it took me many days to do this. It seems like every project is like that, but for some reason, this stuff went extremely slow. Literally took us like 3 solid days to get all this insulation in here. I think I used like 170 bundles. It was definitely way slower than I remembered. I don't know if there was something wrong with the machine, or the last few times I did this kind of insulation, it was fiberglass, and that went really fast. This was quite a bit cheaper, so I went with this, but honestly, with the amount of time that I spent, I would have been better off with the fiberglass. I just like the idea of this, which is basically like newspapers. It's kind of like recycled stuff. I like the idea of that because it seems like it's like less toxic and stuff, but honestly, what does it really matter? You wear a mask, and when you're done, you close everything up, and it really doesn't matter anymore. But anyways, I'm glad to have this done. So now we can move on to installing the heating, and I can already see just by what I did up here, it made a massive difference. So now we can go add some heat, and that will make even more of a difference, so that we're not running the whole building off of 24,000 BTUs. Now we can run it off of a lot more. So right now it is 20 degrees outside, and it is 20 degrees up here. Actually, it says it's 18 over there. So must be doing a lot, because downstairs it's about 60 right now. Code says I need R49 on this garage. I don't think I'm required to really meet that standard, but I did put R49, probably even a little bit more than that. I figured I want to just do it once and get it over with. I don't want to have to go up here and do that again. So I just did the full amount. It says 14 inches. I did more like 16. So I'm going to be installing an air to water heat pump. So let's get into it. Alright, so we've been using this mini split here to heat this shop, and it has not been keeping up too well. It's only 24,000 BTUs. This is 2,400 square feet with 16-foot walls. So I didn't expect it to keep up. It was just something to take the chill off. But it does keep it above freezing, which is nice. So I put in radiant tubes when I poured this slab. So I want to get this hooked up to a manifold. So adding that insulation to the ceiling made a massive difference. This mini split was not able to keep it above freezing in here when it got down into the single digits, but now we can keep it like almost 50 degrees in here in single digit weather. That's a massive, massive difference. And we still don't have insulation on the walls. I have 1/2 inch on the outside. It does help a little bit. Insulating the ceiling was definitely the most bang for my buck. But now we can get the radiant heat installed, and then that will help a lot.
Kind of missing the start here.
No, it's not even.
Oh, that. I'm halfway on this stud here.
Okay, so I don't know how this ended up happening, but for some reason I didn't put the matching supply and return pipes right next to each other. They're every other one, and I don't know how that happened. It's not a big deal, it's just gonna look a little weird down here because like these ones crisscross here. The only thing I can think of, and I think this does make sense now, one loop goes this way and it comes back around the other side, and because of that I didn't end up with them right next to each other. That's the only thing I can think of that makes sense. But again, it doesn't matter. It's just gonna look a little weird down here. I would have really rather it not have done that, but it is what it is. It's not gonna affect the functionality of anything. It was just a little confusing at first, but now I pretty much know what needs to happen. It's good to have 2 extra loops available because we got this hole upstairs that we could put the underfloor radiant heat in, and I don't think that that's on the near future list at all, but it's good to be able to just have 2 extra ports available just in case. We got a lot of crisscrossing down here, but it is what it is. Now I know for next time I gotta really pay attention to that stuff because that really bothers me. Looks good right about there, but then you go down and it looks pretty sloppy. Oh well. So right now I'm going to work on getting the rest of this system hooked up, including the pump, the electronics, the buffer tank, the unit, bringing the power to the unit, communications wires back and forth, blah, blah, blah. There's all kinds of different stuff that I need to get hooked up. But it's going to take a long time to purge the air out of this whole setup here. So I have 10 loops, and I need to get the air out of each loop. And I need to put glycol in it. So I want to start doing that now because it's going to take a long time. It's going to take many hours to do that. So I might as well start that and let it run while I'm hooking up the rest of the system. So basically at this point what I'm going to do is shut off this right here so that it isolates this manifold from the rest of the system, which isn't much right now, but it's still something. And then I got a fill port right here, and I can use this to run back into a bucket. So I'm going to pump the fluid through this, and that should get the air out of it. So if I pump going in the bottom, it'll pump the fluid through the pipes and it'll come back up here, and then the air will come out here. And that I'll have hooked up with a hose going back into my bucket of solution, which is going to be glycol. I'm going to do a 70% solution, so it's 70% glycol and 30% water. So we're going to be using Cryotech, and I want to get this down to, let's see, negative 21 degrees of freeze protection. It's pumpable down to negative 33 degrees, and its burst protection is down to negative 60 degrees. That would be a 75% concentration. So we're going to do 3 buckets of this to 1 bucket of water. We're going to mix it up in this. This is a 27-gallon tote. We're going to pump it out from here with this little Harbor Freight pump. Pumping it into there. Then it's going to pump out and back into here, and it's going to bring the air bubbles with it. So I'm estimating, I can't remember exactly how much tubing I used, but I thought it was somewhere around 3,000 feet, but I'm pretty sure it's less than that actually. I'm just figuring on 3,000 feet as a safe figure because I got 10 loops and they should be less than 300 feet each. And that's going to be between 25 and 30 gallons just from the loops. And then you got like a little bit in the manifold, a little bit in all these lines. We got 15 gallons in the buffer tank and probably a few gallons in the lines that go to and from the unit. So I'm figuring all together probably somewhere around 40 gallons is what I'm thinking. So on this manifold, on the top, on these flow meters, they also control how much flow. You can adjust them all the way out as full flow, or you can go in. And they come from the factory all the way in. So I'm just going to start with the first one, crack that all the way open. These are already open. This is where your actuators would go if you had zones. You'd put a zone actuator on each one of these. But these are a manual zone activator, which you would use in this case. See, there's just this little pin here, and it just pushes down on it. And pushing down closes it, and keeping it up keeps it open. We'll just leave those open and keep these closed except for the one that I'm working on. So these little red things here, you just pop those off because they actually lock it into place so it can't move. So you just take those off and then you can move it. So I like to do the same thing when I'm bleeding brakes on like a car that has hydraulic brakes. I'll open up the bleeder valve, and just like that you put a little hose on the end and you just run the hose upward, and then that way the air bubbles come out, but when you let go of the pedal, it sucks fluid back in, not air. It's kind of the same concept here, except there's not going to be any backflow going backwards for air to go back in, because the pump is going to be constantly pushing air and water through. So the water will come out this end back down into there, and there will be bubbles coming out of there, and that's how you get the air out quick. You can also do it with this pump here and circulate it around, and then the air comes out this air scoop here, but it's a lot slower. There's a very small orifice in here, and it does get the air out, but it's a lot slower. Once we hook up the rest of the system, we'll get the air out with that, and then that will continue to get little micro bubbles of air out.
Welcome to winter.
But quite a bit actually.
quality.
I mean, the concrete slab is like the ballast.
Yeah. Nice.
So now I'm at the point where I'm going to start filling up that tank, which is 15 gallons, and the unit and the lines to and from, so I'm going to guess about 16 gallons altogether. So we just got to mix up some more of that stuff, pump it in. I'm going to pump it in through the bottom here, and then the air is going to bleed out the top and come out here. It's going to hit this, but it's probably going to be too much air for that. So I'm also going to have a hose here to return that back down into the bucket. And then we'll just kind of do a loop here until all the air is out. Once most of the air is out, 99% of it, then this air valve will take out the rest, all the little micro bubbles and stuff. Oh, I guess I need some water. Boy, I had just enough. I probably got 2 gallons left. I still need to fill that line right there. That's about it. So I got enough air out where I just turned on this pump so we can start getting the rest of the air out. You can see we still got some air in there. That's what's nice about this clear tube. This is opener HE PEX. It's also nice having fluid that's red. You can see something. So this particular unit is a 42,000 BTU. They call it a 3.5 ton, and it requires a 30 amp circuit at 240 volts. So that would be 10 gauge wire. I don't have any 10 gauge, but I got some 8 gauge there, so we'll just use that. 3/4 inch flexible conduit. We're gonna run one into a disconnect right here, and then we need to run another for communication wires, and I'm thinking of actually running that right into the disconnect as well. That way it kind of like is just one entry through the wall here on the back side of the disconnect. Okay, that doesn't look the best. Maybe I can come up with a different idea later, but I don't want to block that gauge. I'd like for them to both just come out straight this way, but kind of got to keep one up and one down. I don't know. I think I'll revisit that. Okay, so this unit does not need a neutral, but I'm gonna run one anyways, and I'll show you why later in the video. Right now, let's not complicate things. I'm just gonna run this into here. There's no place to connect it, because normally you wouldn't have a neutral. So inside the unit there is a couple of communications cords that we need to bring inside. One is just like a regular phone cable. This unit has Wi-Fi, so there's going to be a controller inside as well as a Wi-Fi receiver inside. Run these both in this conduit. Alright, so I went to start up the unit and I couldn't get it to fire up. I talked to a guy on technical support and he said that I need a minimum of 8.2 gallons per minute to start this unit up. So it senses the flow and it won't turn on until it's got 8.2 gallons per minute. So I had that little 007E pump, which I always thought was a pretty slow pump, but I went out and I got another pump, which is the Takeo 0015, which seems to account for quite a bit more head loss. So for those of you that don't know what head loss is, basically these loops go out and around and come back, and they're about 300 feet long, maybe a little bit less, but so the head loss on a loop like that is quite a bit actually. And then you add in some elbows and some other 3/4 pecks and valves and stuff, and you got quite a bit of head loss. So I was doing some calculations and I think my gallons per minute was down pretty low. I don't know exactly what it was. Figuring out the head loss is pretty new to me. I don't really know exactly how to do the calculations. I can just get a general ballpark, and I'm really pretty sure that I wasn't even close to the 8.2 gallons per minute. And if you take all these and add them up together, they're only like 1/4 gallon a minute for each one. So if I have 10 of them, that's only 2.5 gallons per minute. And that's with this pump going. The other one was like 1/10 gallon per minute. This one does have quite a bit more flow, but I know I'm still not getting the 8.2 gallons per minute. But I think the guy was mistaken, honestly. I think it handles up to 8.2 gallons per minute, because I got thinking about it, and if you had one zone calling for heat, well, you're not going to get 8.2 gallons per minute with one zone, or even 2 or 3 or 4 zones. So I went back over to this controller and I realized that I didn't have this thing on. So that button was not lit up, but when I went to hit it, it said it was on and it was turning off. So I don't know exactly what happened, but I guess I didn't have the button on. Now it's on, but I actually had this working and I got up to 70 something degrees with it. Right now, because the slab is so cold, I think it's making the unit frost over. So it's in defrost mode right now. I think once the slab warms up the temperature, it's not going to do that so much. And also, I realized that the warmer the water is, the more flow you can get out of it, especially when you have antifreeze in it. So right now my outgoing temperature from the slab is around 46 degrees, and my temperature going to the slab, well, it was up to 70 something degrees. So that's quite a bit of a delta T, but it just started, so obviously it's going to have that big of a delta T. And a delta T is the difference between the incoming and outgoing temperature. Hopefully I'm explaining this to you guys good enough, because it really takes a lot to wrap your head around this stuff. Plumbing is not just pipes and pumps and stuff. It's actually really complicated, especially when you get into heating and cooling. I always told people, I'm a licensed electrician, and I can tell you electrical work is pretty hard, especially to keep up with the new codes and stuff. But plumbing, I think, is even harder. I think you got to really pay attention more with plumbing. People don't seem to realize that. So this unit comes with a Wi-Fi adapter. I'm going to get that all hooked up so that I can monitor this from inside, because I'm kind of sick of sitting here just watching this temperature go up 1/10 degree every couple minutes. It's much better to be able to monitor it from my phone. So I just installed the app on my phone. There's not a whole lot to do on the app, but really all I want to know is the outlet temperature. The return is also nice too. But yeah, so it's heating. It's going to take a while. This is 2,400 square feet, and we're starting out in the 40s, and we need to get it up to 113. That's what I have it set on. We'll play with that when we see what's going on. It kind of depends on the outdoor temperature too. If the outdoor temperature is pretty high, like in the 30s, I'll turn that down to like 90. but when it gets really cold, I'll turn it up. I'm going to see if there's maybe a program that I can do to do an outdoor reset on this. I always wondered why they don't do an outdoor reset based on the weather outside. Like, can't they just connect the weather outside, like on the forecast, to an automated outdoor reset? I'm sure they do, but I haven't seen it. Usually there's a sensor that you put outside to detect the temperature, but the forecast should be close enough. So I'm going to go back inside and monitor this, and I'm going to let it run overnight, and hopefully in the morning it should be up to temperature, and then it'll actually start putting heat out. But remember, I have a 6-inch slab in here, so it's going to take a little while to heat up, but once it does heat up, it will maintain that temperature for quite a while. I always thought that maybe the best thing to do with a big slab like this is let the unit run as hot as it can during the day. That way the air temperature going into the outdoor unit is the highest, so you'll get the best COP. And then at night, you kind of turn the temperature down and let the heat from the daytime heat the place during the nighttime. I always thought that that would be the most efficient way to do it. If you had a geothermal system, it wouldn't matter because the temperature is the same day or night. But in this case, there's probably a 20-degree difference between day and night. So that helps out a lot with the COP. And this thing is not noisy. I can hold a full conversation with somebody right in front of this. And that's 42,000 BTUs. That's quite a bit. It's actually quieter than that other unit over there. And it's bigger. Alright, so fast forward to the next day. I learned a very valuable lesson. Well, many lessons actually. And I want to share with you guys what I learned, because I did make some mistakes and I want to correct them now. And I'm not unhappy about it because I've never gotten any training on doing this kind of stuff. So I have to redo some stuff, but the price that I'm paying is going to be less than taking a master course on this kind of stuff. So originally I started off with this 007E pump from Taco, which is a decent pump, but it wasn't even close to doing what I needed for it to do. So there's several things that you need to take into account when you're sizing the pump for this system. I have 10 loops and the longest one is about 300 feet. So you need to do a head loss calculation for that, as well as other parts of the system too, but let's start with that. So if we have 300 feet of PEX, half-inch, going through the floors, there's no elbows, so you don't have to account for that. If you want to do 1 gallon a minute for each loop, that would be 10 gallons a minute altogether. And for you to do that, you have a massive head loss. It's something in the 20 feet head loss. I think it's actually upper 20s. So the biggest contributing factors to that head loss is going to be the temperature of the loop, which is going to obviously fluctuate. So the warmer the loop, the less head loss you have. So if this is starting out at 40 degrees, your head loss is astronomical. But as it warms up, it gets less and less. Also, adding glycol to the mix drastically increases the head loss. And for any of you that don't know what head loss is, basically that is the friction in the pipe that causes it to slow down the flow. You also get pressure loss from that too, but that's not so important right now. That's more important for like your domestic water inside your house. But for this case, pressure isn't really that important. The gallons per minute flow is important. And every pump has a chart where it has a curve where you can match up head loss on the left to gallons per minute on the bottom, and somewhere where they meet up is what you get. So doing the calculations, if I'm starting out at about a 40-degree loop with 50% antifreeze glycol, which is about what it is. I know I said it was 75, but this stuff is already diluted somewhat. So let's just figure 50% glycol in there. At 40 degrees, at 300-foot loop, half-inch PEX. So I don't have the chart for that pump, but I do have the chart for this new pump, which is a little bit stronger, and I'll show you that. So I don't know if you can see that, but if you have it on high, which is the line that's on top, that can only accommodate for about 16.4 3 feet of head loss. So let's say that we're right at 16.3 head loss. That's 0 gallons per minute. So in order to get even 2 gallons per minute, you got to be down to right at 16 feet of head loss. So we're pretty much at about 0 gallons per minute right now. That's with the loop at 40 degrees with 50% antifreeze and a 300-foot loop, which I think they're all a little bit less than 300 feet, but you have to figure the longest loop, which is probably 280 feet. So right now, we may not even be getting 1 gallon per minute between all these loops. It's very low. But as you're pumping more and more hot water into the system, you're getting more and more gallons per minute. So with that, we're at about 10 gallons per minute. 10 gallons per minute is actually more than enough for what we need here. But, and this is the big but that I didn't realize, you also have to account for the head loss in the rest of the system, which is actually a lot more than I thought. So to recap real quick, this pump is adequate for this 10 loops right here. Only after it warms up though. But it's not taking into account the rest of the system. So the rest of the system has approximately 20 feet of 3/4 expansion PEX. So expansion PEX is nice because the fittings don't reduce, so there's full flow through the fittings. But every elbow counts as far as I can see, a little over 2 feet of pipe per elbow. So we have approximately 20 feet of pipe and 20 feet of elbows, if that makes sense. So 40 feet of pipe. If you use a calculator for head loss on 3/4 PEX at 20 feet, and I wanted 8 gallons per minute, the head loss is a lot. So I was trying to push not only this manifold, which this pump isn't even enough when the loop is cold, I was also trying to push everything through over there with the same pump, which is nowhere near enough. So there's many different things that you could do to remedy this. Number one, the first thing I'm going to do is upgrade to 1-inch PEX going to and from the manifold, going into the buffer tank and into the unit and back. I'm going to upgrade to 1-inch PEX. That will reduce the head by a lot. The other thing I'm going to do is add another pump. I'm going to add that 007 pump going from the buffer tank into the unit. That's going to drastically reduce the head, because basically that takes care of all the head loss in that system, and there's even some left over to help this system. So we're going to call this the secondary system, and this is the primary system. So the primary pump is going to have excess flow to help this. So I could actually put a giant pump right here and just have one pump for the whole system. The problem is what that's going to do, and I didn't even know about this. See that 7.26 feet per second? That's the velocity. That's a really high velocity. As far as what I can see, you want a 4 foot a second velocity or less. You want between 2 and 4 feet per second of velocity. So if you have too much velocity, what can happen is you have a lot of noise, and at some point it'll actually start eroding fittings and stuff from the water just being too violent, basically. If you think of a water jet that cuts through steel like butter, at some point the velocity gets too much for the fittings and the pipe and everything else. So we don't want the velocity that high. So in this system, pretty much no matter what we do, the velocity will never be too high. But if we were to add a giant pump right here, I believe that this velocity would be too high for this system and this system here. So that's why I want to do 2 different pumps. So if you've ever pulled wire through a wall, you know that if you have a spot that's really tough, you want to just deal with that spot at once. You don't want to pull that through
and then go around a corner and pull it through another corner all together. You want to like pull this through first and then bunch it up over there and then pull that through. If you try to pull it all through at once, you could actually damage the wire a lot by doing that. And it's the same concept in plumbing. If you're trying to push with one pump in one spot where there's a high head loss, but there's also another high head loss after that, you're going to end up with a very high velocity. And if you have too low of a velocity, what happens is the air doesn't get entrained into the water, so you have a really hard time bleeding the air out. So you want over a 1.5 foot per second velocity, but under 4. And you may be able to go higher than 4. It's just that at 4, it starts to get more turbulent and it starts to make noise, which I'm not concerned about the noise, but I don't want anything eroding away. So if I just add this pump to the 3/4 right now, I could get a lot more flow out of this system, because that relieves the flow from having to go from here all the way over to there. That just makes it so the flow is here, and then here is a separate flow. But that leaves the velocity too high on the 3/4 inch. So really what I need to do is I need to add this pump in here, as well as upgrade to the 1 inch. That's what I've come up with. I kind of had a feeling that I should have used 1 inch to begin with, but from what I was reading online, I was just trying to see what 3/4 inch pipe could handle as far as BTUs, and everybody was saying that it can handle around 40,000 BTUs. So I was like, okay, well, I'm good to go then. Not even thinking about velocity, gallons per minute, head loss, and then combining these loops together for head loss. Those things just didn't come into play in my calculations, mainly because this is not something I have a whole lot of experience with. But I did tell you guys before that this stuff gets complicated, and now you see what I mean. That was before I even knew about all this stuff. So I went down a lot of rabbit holes last night as far as all the different things that I need to know here, and I'm glad that I got it figured out, but it was not easy to figure out, so I'm trying to explain it in a way where you guys could actually figure it out, at least if you have a head start on something. When you start seeing all these different formulas and calculations and numbers, it just gets overwhelming. So you need to like look at one part at a time and kind of break things down, and then you can actually consume the information and you can like digest it. And now I'm sure that there's a lot more things that are complicated about this that I don't know, especially when it comes time to heat loss in here. I don't know my heat loss, but the unit is sized what it is, 42,000 BTUs, and I just figured anything that can't produce, my mini split can make up for. So I don't think I need to do a heat loss calculation, although any good contractor that does heating and cooling will tell you that a heat loss calculation is the first thing that you do. And I am guilty of not doing that on any of the projects that I've done, but they all work, and they all work very efficiently. So I don't know, either I got lucky or I got lucky, I don't know. But I really didn't want to upgrade to the next sized unit. 42,000 BTUs plus 24,000 for my mini split seems like it's plenty for this building. It's 2,400 square feet, and I'm not trying to heat the upper 8 feet. So with radiant heat, you can do that. You can heat the lower part without heating the upper part. So you don't have to consider this like 4,800 square feet. When you're heating it with that, you do kind of have to figure it as 4,800 square feet, because now you are heating 2,400 square feet times 2. 2,400 square feet at 8 feet, and another 2,400 square feet at 8 feet, because you're heating the air. But with radiant heat, you don't need to do that. And that's one of the reasons why radiant heat is so efficient, especially for taller buildings. There's no reason to be heating up at the top of a 30-foot building when you're only down at the bottom 6 feet. Radiant heat is nice because it stays down low where you need it, and it doesn't heat up top, whereas heating the air is the total opposite. When you're heating air, the air is just moving upward, and so you need to fill all that in up there where you're not even trying to heat, and then the heat slowly creeps down once it's heated up top. To me, that's just super inefficient. radiant heat is efficient. So there's no point in me showing you tearing this all apart and redoing it all. So I'll check back in with you in a little bit and we'll have this thing dialed in. Alright, so this is what it looks like when I switch it to 1-inch PEX. So the supply comes in on the top, goes in there, gets the air out, goes down into that first manifold. It makes its rounds around the building and back into the return, comes out here into the buffer tank, goes down, and then this returns back to the unit. So one thing that I'm not really happy about is the way that the return goes into this tank. There's just really no way to get air out. I don't know if anybody else has ever run into this before. It seems like there should at least be a threaded hole on the top to at least put an air bleeder on there, because otherwise I just don't see how you could get all the air out of here. I'm sure that there's air from here to here, and the only way I was even able to fill this up was to put this on here to let the air purge out of here. This is just a pipe that goes to nowhere, but it's got a little valve right here. So when I was filling this up from the bottom, I was not able to get any more fluid than just on the bottom here. Finally, I had to cut this and put this in here, open that valve, and then I was able to get all the air except from there to there, I'm assuming. But that's the way the manufacturer wanted me to hook this up. I wanted to come in through the bottom and come out through the top, but they said that that's not right. I don't know why they want me to set it up like that, but it's working, so I'm not going to make too big of a deal out of it. So I added that pump right there, and I hung it from that little platform I made, and there's a massive difference right now. Just having that pump on, by switching that to 1-inch, without that pump on, I'm getting a ½ gallon per minute for each loop. So that's 5 gallons per minute for all the loops. Now when I turn that one on, I'm getting about 0.8 gallons per minute, which is actually kind of on the high side. You don't really need that much. So I ended up turning that pump down to medium. But now that I'm doing that, I'm getting a much smaller delta T. I'm getting about a 10-degree delta T. So right now, let's see. Right now I got my outlet temperature coming from the unit at 85, and it's coming back in at 70. So actually that's a 15-degree delta T, but it's not normally like that. But I have it set up for 90 degrees, so eventually it'll get to that point. It's been taking a while though. This slab took a long time to heat up. Like, I've been running this non-stop for about 4 days now, and the slab is just now getting up to temperature. But I kind of knew that. Now it should be able to maintain the temperature pretty easily. But yeah, just to go back and reiterate on this, changing to that 1-inch PEX made a massive difference. I'll never do that again. Unless you have a really small building, 3/4 just doesn't cut it, even with this expanding PEX. The head loss in just those pipes alone is a lot. And I know that when I was going over head loss calculations before, I was talking about 40-degree water and stuff, and I don't think that that really even matters, because you're supposed to give the average temperature when you're doing the calculations, and 40 degrees isn't really part of the average temperature. I was just putting it in there for starting up the system. And also, if you're away for a while and you don't have the system running for 2 weeks or something, your slab could get down pretty low. So it would do that again. So when you're down to that point, your flow is very low. But I don't know if that really matters. I think you should average your temperature for calculating your head loss in the 80 to 90 degree range, because that's pretty much what you're going to be running it at most of the time. Having that glycol in there and having a very low temperature for starting the system makes some really sluggish water. But again, I don't think that that really matters other than when you're starting up the system. So that tank has 2 inches of closed cell foam on the side and 3 inches on the top, but it still radiates a little bit of heat. So yep, looking pretty good. So now you can see the floor has quite a bit of heat. It says that the floor is 65 degrees. That's a little lower than I thought, but it's doing the job. So let me show you something cool over here. This thermal imager. Somewhere's right here I have, right there, yeah. Right there is a big spot that I left the pipe out because I'm going to put my lift there. That's the footing for the lift. So I didn't want the pipe going through there because I got to drill some holes. So that's one spot, and then that's the other spot. That's how you can easily find those spots. Although I did leave some calculations so that I don't have to search for it. I can calculate it off the walls. I am going to be installing that lift pretty soon. It's just I don't exactly need it right at the moment, so been doing other things, been working on other stuff. But yeah, you can see the floor is very hot compared to the walls. The walls are very cold, and you could understand that because there's no insulation on the walls. There's only a little bit on the outside, and that's another thing too. I'm sure it would help a lot if I had insulation on the walls. A ½ inch insulation on the outside is doing something, but it's not doing a whole lot. It is keeping the walls from condensating though. So that's a good thing, because I don't want the walls to be rotting out because I didn't get the insulation in. But yep. It's almost a little depressing when you use one of these because you realize how many little pinhole leaks you have all over the place. That's why ICF construction is so nice, because you don't have to worry about that. ICF is just a liquid and then it turns solid and there is no air leaking whatsoever. But it's a garage, so I'm not too worried about it. Let's see what the ceiling looks like. The ceiling's pretty warm. Definitely pretty warm compared to the walls anyways. See what that mini split looks like. Look at that. When I first started the system up, you could actually see the individual pipes, kind of. They're all the way on the bottom of the slab, so you can't see it like you would on a house that's got underfloor radiant heat, or even in my house where it has a thinner slab and the pipes are closer to the surface. That heats up a lot quicker. And here it's going to take a while, but once it's heated up, if I lose power, I would be good for probably a week before I got below freezing, because this slab would just keep radiating heat. So I put this little Nest thermostat in here. I just had the door open for a while because we were doing some work in here and it got kind of dusty, so I had the door open for a while. That's the only reason the heat is not keeping up at the moment, but it will catch up in a little while. So this is what the unit looks like when it's all said and done. Like I said, I may revisit that and do something different. For right now it works though. I actually like the way that this thing looks. I like the colors and everything. It just looks kind of sharp. But I guess all that doesn't matter unless there's good results from it. And I'm happy to report that there is good results. I've been using this for about a week now, and it's been everything I expected. The shop has been very warm, and it's a different kind of warm because now you can get towards the floor when you're working on something and it's still warm, which is nice. Because before, the warmth was up to the ceiling, and as you got lower, it got colder. Still very tolerable with that other unit in there, but this unit has really been saving the day. It's been taking the brunt of the heating. That thing I'm still using right now simply because it's hooked to some solar panels, and it would be a waste if I didn't use it, because right now I have it set to not use any AC. It's only using DC from the solar panels. It's called AC limiting, and so during the day that thing runs quite a bit only because it's using free energy. So this one works at night and also during the day too, but its main job is at night. So when it gets a little bit warmer out, I'm gonna put about 60 panels on the roof, and I'm gonna get somewhere around, I think it's like 20 kilowatts. So then next winter we can mainly use this one, and that one will be like the supplemental heat. But that way the solar will take care of this, and this will be running for free, and those solar panels won't be hooked to that anymore directly anyways. But you can see I'm talking to you guys. I'm 3 feet away from this unit, and it's no problem at all. It's very quiet. Not like that really matters, because back here I don't really care. It could be extremely loud, it doesn't even matter. But it's good to know for somebody who wants to install it on their house, especially if you have neighbors, or it's just outside of your window while you're sleeping. It is a very quiet unit. It's actually quieter than that other one. Part of that though is because I have it on a concrete slab, and this one's mounted on the wall. And you could mount this one on the wall too, but I didn't want to do that on this one simply because it does make some vibrations go through the wall because of that. So if I was to do that one over again, I wouldn't put it on the wall. You can see how much water is underneath this one. That's from every time it frosts up, it goes into defrost mode, and then water comes out the bottom, and get the pile of ice underneath because of that. This one did have that, but it melted off yesterday. One thing to note about this unit is it's a DC inverter unit, and so therefore there's no hard starts on it. You don't need a soft start. And the units that are not inverter, even when you have a soft start, it's still a hard start. This has 0 start. It literally starts at a few watts and just keeps ramping up from there. It's just like that other unit over there. It just starts from nothing and goes all the way up. So there is no more amps needed than what you are actually running at full load, which is really nice, especially if you're off grid or something. You don't really have a whole lot of surge power. My geothermal unit in my house is one of the best you can get, and it has a soft start, and it still flickers all the lights in the house when it starts up. This company actually does make a water-to-water geothermal unit that is a DC inverter, but I already have one, so it's not going to do me any good. But just so you guys know, if I was to do this 2 years ago before I put in the geothermal unit in my house, I would have certainly went with this unit instead of a geothermal unit, because this is literally 20 times less work and 20 times less cost too. This unit was under 4 grand for it, and to install this, not including the radiant part of it, which you would have to have anyways, whether it was geothermal or a gas boiler or whatever, just putting this unit in, you can easily do it in a day. And that's if you've never done it before. You could do it in a few hours if you have done it a few times. That's a massive, massive difference from the geothermal unit. Even if you have a well, which I didn't, I had a pond loop, but even if you had a well, you're still like a week installing that thing. Plus the cost. I probably have like 60 grand into that unit in my house. Now that's including all the manifolds and the fan coils and all the other stuff, so it's not that for the unit, but I'm just saying, if I went back in time 2 years, I would definitely get this unit in my house. I'd probably install either a bigger one or 2 of them, because I would just want to make sure that I had the right amount of heat in my house. In the garage, it's not so important if it doesn't keep up. But I've had it down to single digits already, and it seemed to be fine. And I don't need it to be that warm in here. Like 60 degrees is more than warm enough in here. So I was figuring 20 BTU per hour per square foot, and that's about what I have right now. And this unit is just under that. But that's to heat it up to like 68 degrees, and I don't need to get it up to 68. If I want to get it up to 68, I use that in conjunction with it. But yeah, I could have saved a boatload of time and a boatload of money if I had went with one of these units. Even if it wasn't this brand, which by the way, I bought some fan coils from them a while back. They seem to be working fine. They do have very affordable units, but there is other air to water units as well. I have no affiliation with these guys, but I will leave a link for you if you want to check them out and check out all the other stuff they have. They seem to have very good customer support anyways. You call them up and there's usually somebody there to answer your questions pretty quickly, and they know what they're talking about too. And like I said, they also stock geothermal units. They also do like wood boilers and multi-fuel boilers and stuff like that. They have a bunch of different stuff, so check them out if you want. But anyways, I guess that's it for this video, guys. I gotta get going on some other stuff. Heat is nice, but it's not the most important thing in my life right now, so I gotta get back to other things. So I will catch you on another video.